abagagga bibakosa. Mulimu ebiseera lw'onoonya okuwummula naye ne kubula. Nze bino bye bimu ku bibadde mu lugendo lwange olutuuse. Nakula na maama ebya taata sibimanyi nnyo nnyo. Twabeerangaawo ne maama ng'ennaku ezunza. Yali mukazi mukozi ayagala abaana fiyawo ku lw'abaana. Ebyokulya nga bibula lwe mugunye nga mulya lwe bibuze nga muguma. Abaloga nga baloga endwadde zaaluma bali obulungi baseka. Kale nze okubeera wano okubeera kino Yesu yanyambye era ye munnange. Yeggwe munnange, yeggwe munnange, yeggwe munnange, kuyita munnange, yeggwe munnange, fuuka munnange, taata yeggwe munnange, kuyita munnange, baseba abatuddeeyo, banyaba abatuddeeyo, musembere mbalage munnange, ono ye munnange, afuuka munnange. Ebigambo bya maama bwe yabanganyize byammalangamu amaanyi. Ndi mukazi munaku, ndi masikini, ntambula mpita mizimu. Teyalina yamba, teyalina ssuubi, teyalina future. Singa nali nkuzeemu oba nandikoze ssente ne nsanyusa.
This is OPERO Stephen taking you through a tutorial of Principal Mathematics 425/1. Today we are actually heading to a topic, trigonometry, and we are going to discover some basic information about trigonometry as we expand our understanding on trigonometry. But before we embark on anything, let's thank God for the blessing. Heavenly Father in heaven, we thank you for loving us. As OS, we can't surely continue unless you guide us. Give us the wisdom, knowledge, and understanding required in this particular tutorial. All this we pray through Jesus Christ, the Son, who lives and reigns within the unity of Holy Spirit. Thank you, Lord. Thank you, Jesus. My friends, allow us get into this trigonometry. There are very simple things that I want us to discover today. And by the end of this tutorial, you should be in position one to appreciate that there are 4 quadrants in a unity circle. When we get an XY plane to bisect a unity circle into 4 portions, we shall get to realize that we measure angles right from the positive x-axis, and this can be either anti-clockwise, and that is when the angle is positive, and clockwise when the angle is negative. We shall also get to realize that in each quadrant there are 3 trigonometric ratios: sine, cos, tan, and also their reciprocals have different signs in these respective quadrants. We shall get into a situation where we shall solve trigonometric equations, and we shall get a range within which we expect the solution set of a given trigonometric equation to lie. And guess what? I will direct you to do some activities, and we shall close the chapter with other activities. And in case you need the scenario based items, I told you, just prepare that money and afford this book. It has all the activities, the scenarios that you want, that you need as far as this topics are concerned. To start with number 1, I will look at the general angles. Now, if you look at the general angles in this context, taking a case where we have the XY plane bisecting the circle into 4 quadrants, as you can see, where I have the first quadrant, second quadrant, third quadrant, and finally the fourth quadrant. And we realize that as you're measuring the angle, unless the case for bearing, for case of angles, you measure angles right from the positive x-axis, that is OX. If it is clockwise, then that angle will be a negative, and if it is anti-clockwise, this is when you have anti-clockwise, the one moving, that angle is a positive. Then if it is clockwise, then that angle is a what? Is a negative. Clockwise is a negative. So we measure angles from the positive x-axis. I repeat, if you're taking a direction of anti-clockwise, then that angle must be a positive, and anti-clockwise, that angle must be a negative. I repeat, this is a positive and this is a negative. Another thing I want us to realize is that the first quadrant, if the angle is theta, in the second quadrant, to get the angle in the second quadrant, I get 180 minus the angle in the first quadrant. In the third quadrant, if I want to get the angle in the third quadrant, I will get 180 plus the angle in the first quadrant. Then in the third quadrant, I will have 360 minus the angle in the first quadrant. So that's how we are going to treat angles in these quadrants. And just in case I get the angle in the first quadrant, then I can get the other angles in the remaining 3 quadrants. Check here. Which angles do I expect to be in the first quadrant? These are angles that are ranging from 0 to 90. I will call them acute angles. 30 degrees, 45 degrees, 60 degrees, 55 degrees, name them. In the first quadrant, I expect that. So I expect angles from 0 to 90 in this quadrant. Then in the second quadrant, I expect angles from 90 to 180. In the third quadrant, I expect angles from 180 to 270. And lastly, in the fourth quadrant, I expect angles that are within the scope of 270 and 360. Hope I'm very clear. So that is very, very important as far as the angle properties or the general angles are concerned in this context. Okay, let's get to number 2. We are looking at trigonometric ratios. They are basically 3, and also their reciprocals. So I will take a case where I have the xy plane still bisecting the circle into 4 equal portions or quadrants, whereby this is the y-axis and this is the x-axis. Now this axis, you can see they are dividing this circle into 4 equal portions. And these 4 equal portions, I called them the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now in these quadrants, I have right-angled triangles, as you can see them. The first right-angled triangle in the first quadrant is that one. The second one in the red color, in the red lines. The third is in blue line, and then the fourth in the fourth quadrant. The third is in green, and then the fourth is in light blue, Now you get to realize that in the 4 quadrants I have 4 right angled triangles. Now since this is the xy plane, it means that I have a Cartesian grid, whereby I have the negative parts of the x-axis and the positive parts of the x-axis. Also, on the y-axis, I have the positive parts of the y-axis and also the negative parts of the y-axis. Now, we are going to look at each triangle. If you look at the first triangle, the positive x-axis, the x-axis is positive, the base of that triangle is positive, and the height of the triangle is positive. In the second quadrant, the base is a negative and the height is a positive. In the third quadrant, the triangle we have, the base is negative, the height is also negative. Then when you look at the fourth quadrant, the base of the right angled triangle is a positive and the height of the right angled triangle is a negative. But throughout all these triangles, we are seeing that they have the same hypotenuse. Basically, this is the distance from the center to the circumference on each triangle, and that is what we call the radius, the distance from the center to the circumference. So at that point where the triangles are formed, the line from the center to that point meeting the height of each triangle, that line is the radius, and it's of a unit length r. Now since this is distance, we can't have a negative distance, so that distance is in a positive digit if it's a digit, so it's a positive in other words. Now we are going to get to SOHCAHTOA, where we shall look at sine as opposite over hypotenuse, cos as adjacent over hypotenuse, then tan as opposite over adjacent. SOHCAHTOA. And we are going to look at also the reciprocals of this cosine, sine, and tangent of this angle. Now I'm looking at the angle as theta. This theta can be 30, 40, 50. So this theta is in the first quadrant. Now being that these triangles are of the same dimension, of the same size, it means that by similarity we are using the concept of a unit circle. However, in this level we do not go into details of a unit circle. We discuss much of it at the university level. But now what we just need is that getting these right angled triangles of ultimately the same size, such that these angles, using the property of angles, you see that these angles are vertically opposite, they are the same. And now if you look at the triangle in the in the second quadrant, and triangle in the third quadrant, this horizontal line is bisecting that triangle, meaning if this side is 30, even this side is also 30. Now you see that the angle theta in the second quadrant is vertically opposite to the angle theta in the fourth quadrant. So that's why we are having theta theta throughout. It is because of that property that we study in P7. That property we study in P7. Now I want us to apply SOHCAHTOA on each triangle, and I want us not to forget how to get sine, cos, and tangent using each triangle. Now in each triangle you should be in position to look at the opposite of that angle theta in each triangle, the hypotenuse of that angle, and the adjacent of that angle in each right angled triangle, irrespective of the stand, whether it is upside down or upright. Just be in position to look at the opposite of that angle, the side that is opposite to that angle, the side that is adjacent, and also the side that is acting as the hypotenuse to that, or the hypotenuse of that triangle. Then as you're substituting the sides, I've already given you positives and negatives and r. put them with the signs, because I'm interested in the sign you get after doing the operation. So let me start with SOHCAHTOA. In the first quadrant, I'm using SOHCAHTOA. Sine of theta, of course, the opposite is positive y, radius is the hypotenuse, and I'm getting a positive. So sine is positive in the first quadrant. Cos of theta, I'm still using adjacent over hypotenuse, and that is a positive x over r. So cos is positive in the first quadrant. Tan of theta, I'm using positive y over positive x, and everything's a positive. Meaning sine, cos, and tan of this angle is a positive in the first quadrant. Let me move to the second quadrant. I still start with the sine. So in the second quadrant, the opposite is positive y and the hypotenuse is positive r. Then I get a positive. So sine is positive in the second quadrant. In the second quadrant, still for cos, I think adjacent is a negative. Then the hypotenuse is a positive. Then I remain with the negative. Tan of theta, tan we said is opposite over adjacent. Opposite is positive y and adjacent is negative. Positive divided by negative and made with the negative. So tan is negative in the second quadrant. Meaning in the second quadrant, it is only sine that is positive. And when you are solving a trigonometric function and you find a situation where you need to get other angles after obtaining the key angle, for you to locate other angles, for the case of a positive, you go to the quadrant where sine is positive. And I told you, how do we get other angles in each of these quadrants? In the first quadrant, it is always the key angle. In the second quadrant, 180 minus the key angle. In the third quadrant, 180 plus the key angle. Fourth quadrant is 360 minus the key angle. Let's look at the second last quadrant. That's the third quadrant. Sine of theta, of course, it's now an obvious thing now. The right angle triangle is there. We get to realize the sine of theta is a negative. Cos of theta is also a negative. It is only tan of theta that is a positive. So it's only tan that is a positive in the third quadrant. Lastly, in the fourth quadrant. Fourth quadrant, sine is a negative, cosine is a positive, and then tangent is a negative. So it is only cos that is a positive in the fourth quadrant. Now mathematically, the item taker should be in position now to memorize this, and we shall use very many different acronyms that will give us a point of remembrance on these signs of the trigonometric ratios in each of the quadrants. And we are realizing that in the first quadrant, all are positive. So I will use capital A. In the second quadrant, it is only sine that is positive. I will use capital S. In the third quadrant, it is only tan that is positive. I use capital T. Then in the fourth quadrant, third, then fourth quadrant, I will use capital C, because it is only cos that is positive in the fourth quadrant. Now to use an acronym that can help us to memorize this, I can say all students take chemistry. Of course, that is for O level, not in A level, please. Just to help us keep with this concept of the signs of trigonometric ratios in the four quadrants at the fingertip. So I will use all students take chemistry in O level. I can say all students take coffee. And that will give us an overview of the trigonometric ratios. Now there's what we call the reciprocals of these trigonometric ratios. A reciprocal of something is 1 over that thing. For example, if I give you 20, the reciprocal of 20 is of course 1 over 20. Now the three trigonometric ratios are sine theta, cos theta, and tan theta. If I want the reciprocals, I will just get the secant of theta, which is sec theta, defined as 1 over sine theta. Cosec of theta, that is the reciprocal of cos theta. And lastly, cotangent of theta, which is also defined as cot theta, also termed as 1 over tan theta. Now, the reciprocals of these three trigonometric ratios share the same sign in the quadrants you are defining them. For example, if you are talking about the reciprocal, that's sec, cosec, and cot in the first quadrant, they do share the same signs as the signs of their original trigonometric ratios. The same thing with the second, third, and the fourth quadrants. So 1 divided by positive sine theta does not change anything. A positive divided by a positive remains a positive. A positive divided by a negative remains a negative. That's why sec remains a negative. Sec remains a negative in the third quadrant and also the fourth quadrant, because in those quadrants sign is negative. I repeat, cot, for the case of cot is negative in the second quadrant and also the fourth quadrant, because in those quadrants that is when or where we find tan as negative. So they share the same signs. So the last part of our discussion on this very slide, we are realizing that we need also to negotiate on the trigonometric ratios for angles. I uploaded this already in the system. Check for that video, how you can get 30 degrees, 45 degrees, and 60 degrees without using a calculator. Why do we need to do that? Because at some point we shall be solving these trigonometric functions or trigonometric equations, and you will be required to prove at some points, of course depending on the scenario, but instead of actually just pressing on the calc sine of 45, you will need to play with something to represent sine of 45. Instead of pressing on the calc cos of 60, you will need to use the set square or use the special angles trigonometric ratios for special angles, and use their respective values to help you prove a certain identity, if a proof is on your desk. So basically that is it. Unless you have a question, leave that in the comment section. And we have seen that now we can now hijack the trigonometric ratios, in terms of the signs they possess in each quadrant, and the reciprocals and so on. So trigonometric equations, we need to solve something here. There's a note. Trigonometric equations have a number of unlimited roots. That is why the range of the required roots is always stated unless a specific or general root or angle is required. I think that is very clear. These roots can be in a range of degrees, that is negative 180 degrees less or equal to theta less or equal to 180 degrees. Once you see less or equal, it means these angles within which the range within which the angles are expected, or the angle is expected, the range is also inclusive. Meaning when you solve and find the answer as 180 degrees, you have to include it in the solution set. Or in radians, negative pi less or equal to theta less or equal to pi. meaning a student should be in position to know how to convert from degrees to radians and also from radians to degrees. So if the required range is in rad, then the item taker must convert degrees to radian. I'm using one or two examples here, then the task will be yours. Converting degrees to rad. Of course, I used this simple formula. K is equal to theta over 180 times pi, where K is the required angle in radian and theta is the given angle in degrees. I tried this example. Now, if the given angle in degrees is 45, I want K. Where theta is, I just put 45 and I press. It is better to leave your answers in fraction unless otherwise. Substitute. Guess what? My K will be pi over 4 radians. Therefore, 40 degrees is equal to pi over 4. Convert radians to degrees. I will use the same example, pi over 4, and I want to check whether it will give me 45 degrees. Instead, I will use theta is equal to K over pi times 180, where theta is the required angle, and K, this is K please, and K is the given angle, but this given angle is in radians. So when I substitute, I get my, in this example, when I substitute, of course I'm converting pi over 4 to degrees. So when I substitute, guess what? I get my angle as 45 degrees. Therefore, pi over 4 radian, pi over 4 is equal to 45 degrees. I think that is very clear now. So your activity is here. We will do that activity. Now in this example 1, I want us to solve trigonometric equations. I will try to solve some, then much of it will be you doing them, and you will be comparing the responses you have with the expected responses I have already created for you. There are over 10 questions, kindly tasks that require you to just solve the trigonometric equations as you compare the response with what we have. Then after this episode, I will upload some scenario based items on this very part. So don't forget to subscribe, don't forget to share these videos, don't forget to comment, don't forget to like. Why do we need to do this? It is the only way you will be receiving current updates on everything we post on this podium. So don't forget to share. I told you, love is sharing and giving. If you know something, the best thing you can do for your friends is to let them also know. My brother, my sister, all is vanity. But what you can do is very simple. Share that smaller thing you have. Tell him or her brother there is a system here. We are trying to hijack this thing online. Can you also tap on that link and learn something? That's the only thing that you can do that will help us to push the channel. Otherwise, let's try this. Solve the equation, and the equation is cos theta is equal to 0.5 for the angle 0 degrees to 360 degrees, but inclusive. I told you when you see less or equal, it means that even the angle 0 degrees and also the angle 360 degrees, once you get them as the solution, then you have to include them. However, if it was just less theta, less 360, then we do not include these angles, the 0 degrees and the 360 degrees. So the expected response, what I will do is I will take the cos inverse, and the cos inverse of 0.5, press in my calc, I get 60 degrees. Now 60 degrees is the key angle. Now I need to get other angles. How do I get these other angles? In the first slide I told you, taking XY plane, bisecting the circle into 4 quadrants, then I'm in a position to find the other angles as long as I identify where the cos, for this case I'm treating a cos, as long as I identify where the cos is positive, because even when we are treating here everything is positive. So where the cos is positive, I remember telling you all students take coffee or chemistry. Now you get to realize that cos is positive in the 4th quadrant. And I told you in the 4th quadrant, to get that remaining angle after getting the key angle, we subtract 360 minus the key angle. And that angle you get, that will be 300 degrees. 300 degrees. This is the angle whose cos, when you press this, the cos of 300 degrees, you get 0.5. 0.5. Meaning 300 degrees is another angle that is related to the key angle 60 degrees. Please, I want us to discover very many things as far as solving these trigonometric equations are concerned. There are very many new concepts that once you mess up with, you may not come up with a suitable solution set of the values of the angle you are solving. Now, I want us always to be in position to confirm our answers. After you've solved the values of theta, the values of x, if the trigonometric equation is in form of x, in terms of x, try now to press if it is a cos of that angle you've got. If it gives you the original thing you have as 0.5, then that angle qualifies to be a solution set. Please give yourself time to press the calc and confirm your responses. So now I will not mind about the 2nd quadrant and also the 3rd quadrant, but only I will concentrate on the 1st quadrant because cos is positive. Let me use something else here. For example, cos. How about if it was cos theta is equal to negative 0.5. This is very important also. So for this, I will still take the cos inverse. Theta is equal to cos inverse. See, someone stole my pen, so I'm still trying to learn this soft pen. So since what we are solving, it is angle, it is a negative, I will not put here negative. I will just press 0.5. Now, what is the importance of this negative? The importance of this negative, it is just going to help us locate on these quadrants where cos is negative. Please, that is the importance of that negative. Even if it is a sign, the importance of a negative on what you're taking a cos inverse. Before you take the cos inverse, first eliminate that negative. I'm explaining something here. Now, when you press the calc, you will get that answer as 60 degrees. 60 degrees. Now, this is the key angle. There are possibilities of recording this key angle as you're summarizing the final angles that satisfy the solution. And also, there are possibilities of not recording it. The question is, when do we record this key angle? 1. When the key angle is as a result of taking the cos inverse, sine inverse, tan inverse of what was originally positive. we consider the key angle. Are we together? 2, we consider the key angle however much what you are taking the cos inverse, the tan inverse, and the sine inverse of is originally a negative, but on a condition that the range given includes negative angles. I don't know, no kudono. Check here. If it is now a negative for this case, you look at our range. Our range is including only positive angles. Are we together? So this one means the key angle, we shall not consider it, because the key angle is just going to help us get other angles. The key angle is just going to help us get other angles. However, for cos, it is quite tricky that even if you take negative 60, cos of negative 60, you still get a positive 0.5. So cos of a negative is the same as cos of a positive. But now, even if it is a cos, there are possibilities of us ignoring the key angle on a condition that the given range does not consider negative angles. Are we together? For a cos, then if the given range has negative angles and you're treating a cos, then even the key angle will be considered, the positive key angle and the negative key angle, because for cos takes consideration of a negative and also a positive. And why are we taking a negative? It is because the range counts for negative angles. Now, after knowing that my cos, the key angle I have, is helping me to get other angles that are related to this key angle, I just use the negative to locate the quadrants where cos is negative. Now I come to my all students, take chemistry. I look at the quadrants where cos is negative. Guess what? That is in the second quadrant and the third quadrant. How do I get those angles? I will get 180 minus 60 in the second quadrant, and in the third quadrant I will get 180 plus 60. Now those two angles are the ones that when you decide to press the cos, they give you a negative 0.5, a negative 0.5. But when you just press cos of 60, the answer will be a positive 0.5. That's why I'm not considering this 60 as the key angle for the case when the range is not in negative considerations. I said solving trigonometric equations has very many things to do, that I want you to pick this. And while going through these tutorials, don't think you will just pick these things in one day. Learn something and pause there. Internalize it, digest it, then you continue. These are lessons taking 15 periods for you just want to hijack it in one night, because the video is showing 2 minutes, 5 minutes, 20 minutes. You just don't know the time someone uses to upload these videos. So it is something that is time bound, and you need to structure it in such a way that if a video is for 1 hour and 30 minutes, those are about 4 or 5 sessions of learning that thing, unless you already have some information about it, so you are just going through it to confirm what you have. Anyway, that was a by the way on that. Allow me continue, but before we continue, let's erase some of this this thing here. By the way, this is just a by the way, please. And for your own information, this is your own work that you need to read. I'm trying to simplify life here for you, such that you also add on what you have. But just know the activities are waiting for you. They are very interesting, very, very interesting, and I pray you go through them. So the other angles that are related to 60 degrees, whose cosine is 0.5, we can see them as 360 minus 60 degrees. So since cosine is positive in the fourth quadrant, another angle is 300 degrees. Therefore, the required angles are 60 degrees and 300 degrees. So example number 2, we are solving something of that caliber. Sin 3x is equal to 0.3572 for the range negative 180 degrees less or equal to x less or equal to positive 180 degrees. This one means negative 180 degrees and positive 180 degrees are inclusive, just in case you get an angle that is equal to them, so you include them. Now something unique is here. You get to realize that what we are solving is a multiple of 3, so 3x. So for me to accommodate the angle 3x, I need to increase the range given. So I will increase the range, so I will get a new interval. That is after multiplying through by 3. And I will get something of that caliber, which is negative 540 degrees less or equal to 3x less or equal to 540 degrees are positive. Now, why do I need to do this? Because the angle I'm solving has a multiple of 3. It is 3x. So if it is a 2x, 2 theta, 4 theta, you also multiply the angle such that you increase. And why do we need to increase? We need to look for all other angles that will give the output of that will give us the output in such a way that when you press the sign of those angles, the final answer will be 0.3572. If you don't increase the range for this multiple, then you will only get a few that will not be complete. So as usual, I remain with 3x this side. I take sine inverse. Guess what? I will get my key angle. For this case, I'm considering a key angle. Why am I considering the angle key? One, it is that first and foremost, the range given is including even negatives. But we are so lucky that our key angle is as a result of taking the sine inverse of something that was originally a positive. However, even if it was that what we are taking the sine inverse was originally negative, still we could take the key angle. Why? Because the range counts for negative angles. Are we together? So my first angle, I've got it as 20.93. Now, on this level, don't try to reduce such that you solve for x, even if it is 2x is equal to 20.93. Don't rush to solve for x. First, get other angles that are related to this key angle. Then, as you're concluding, you divide those angles by 3, such that you remain with the x that you're solving. Here we are solving for x, not 3x. So learners sometimes misfire that with just rushing to solve for x, then they use the new value of x here as the key angle and everything becomes wrong. There will only pass one angle, the rest will be incorrect. So other angles that are related to 20.93 degrees, whose sine is actually 0.3572, are in the second quadrant. Actually, there's only one angle in the second quadrant. And why am I taking the second quadrant? It is where the sign is positive. So I come to my quadrant, the first one, second, and second, third, and fourth. Here all Take chemistry, all students take chemistry. Now automatically in the first quadrant I have that key angle, always have that key angle as 20.93 degrees. Now I get into the quadrant where sign is positive, and we are seeing it is in the second quadrant, and we agreed in the second quadrant it is 180 minus the key angle. 180 minus the key angle. So the angle I get in the second quadrant is very correct, and I will consider it. So since the new range is also increased to negative 140 degrees less or equal to 3x less or equal to 540 degrees, and this new range is now greater than 360. You see, every time you create a new range, look at the new range you've got. If it is greater than 360, by all means you are going to play what I'm about to play in the next step. Are we together? So what I'm going to do is I will add 360 on the key angle, and also that 360 on the second angle I've got in the second quadrant, because the second angle in the second quadrant is 159.07 degrees. So I just keep adding 360 on them. I just want to get other angles that accommodates 3x. So I'm getting now 360 plus the key angle, that is 380.93 degrees, and also 360 degrees plus the other angle that is related to the key angle, which is 519.07 degrees. I've got those angles. Then the last way of getting the remaining angles is looking at the negative angles. Why do I need negative angles here? It is because the range is a negative. The range given is counting even negatives. And then two, when I look at the range I have, the new range, it is still negative. Are we together? So now what I'm going to do is I get back to my original range. I pick the upper limit and add it on the key angle. Are we together? Get the upper limit, add it on the key angle. After adding, include a negative on it, because you are looking at the negative angle. You are measuring this angle but in a clockwise way. So that's why I will get 200.93 degrees. And that is a negative angle. I'm measuring it anti-clockwise. Also get that very 180, the upper limit, add it on the other angle that is related to the key angle. Attach a negative. You are measuring it clockwise. I want negative angles, and that will be negative 339.07 degrees. I think now I've exhausted all the angles. I have over 1, 2, 3, 4, 5, 6 angles. Now these 6 angles, I need to divide them by 3 by 3 by 3, because they are just equal to 3x, and yet I need x. So I divide everything by 3. So when I divide everything by 3, in the next level, I have to reduce them and arrange them in ascending order. And therefore, the value of x will be negative 113.02 degrees, negative 66.98 degrees, 6.98 degrees, 53.02 degrees, 126.98 degrees, and lastly 173.02 degrees. These are the angles whose sine, when you press sine of negative 113.02 degrees, when you press that sign, the answer is 0.3572. So as you're concluding here, you try to test by pressing the sign. Since I'm treating a sign here, press the sign of 6.98. Do you get 0.352 degrees? Press the sign of 173.02 degrees. Do you get the answer as 0.3572 degrees? If it is yes, then you are very correct. This example, please, if you're not understanding it, rewind it again and play it. This very example is very important, most especially when what you're solving has a multiple of a digit, 2 theta, 4 theta, 5 theta, 8 theta, and all that. You have to increase the range and you cover up all the angles that are required. Now if you look at my range, is actually greater than 360, so I will just do that. And you have very many questions of this caliber in this very tutorial that will require you to apply the same knowledge. Good enough, I did all of them and the responses are just attached adjacent to each. So you do it, then you compare with the responses. Allow me project you to activities. So activity number 1 is there. The expected responses are there. Activity number next is there.
Ni webasa Mukama bwe nakulakula mama wange yanyumiza ku biseera by'entano. Ebiseera ebyo byali byannaku abalungi abatugenda ku nfaafa, abamu byabatwalira ssente, balala byabatwalira nkanda, abantu nga battibwa mmundu, ne maama oyo yandifudde era wandikuze nga taata taliiwo, naye Mukama ye yayamba oyo kyoboolaba kuyita munnange, anze yamponya nnyo nnyo. Yegwe munnange, yegwe munnange, yegwe munnange, yegwe munnange, kuyita munnange, yegwe munnange, fuuka munnange, taata yegwe munnange, kuyita munnange, baseba abatuddeeyo, banyaba abatuddeeyo, musembere mbalage munnange, ono ye munnange, yafuuka munnange, yegwe munnange.
Remember where you got it from. www.djericom.com